Okay, guys. So today we'll go through logistic regression. So now the use case, like use case of this. This line will be called as z equal to 0. So how do I convert that? Like I want a formula which converts this to probability. Now that formula is known as sigmoid. So aim of logistic regression again to find the optimal value of theta 0, theta 1, and theta 2. These are called model parameters. Okay. So this is the formula for logistic regression, which is sigmoid of linear regression. That's all. Okay, guys. So today we'll go through logistic regression. So what do you think? Which kind of algorithm is it? Like classification or regression? Any guesses? It's a classification algorithm, which means that it is used to like the target variable for this will be categorical. Okay, like it will contain values like 0 or 1, for example. Okay. So this is how we differentiate between regression and classification. So even though it contains regression in the name, but the reason is because it is just one step ahead of linear regression. So it's a classification version of linear regression. So now the use case, like use case of this, when to use logistic regression. So suppose you have data like this. You have x1, you have x2, and you have y. Okay, this is the kind of data that you have. So there can be more x's like x1, x2, x3, x4, but just for the sake of visualization, I am taking two. Okay, let's say you have a data like this, and you say x1, let's say x1 is 1, 2, 3, 4. X2 is, let's say, 5, 7, 10, 11, and y is, let's say, 0, 0, 1, 1. Now you have to classify like what y is. So you have to train a model for this. So what you will do is you will try to plot it first because we want to see the use case. And let's say there are more examples. And after I plot this, I get a graph like this. So I'll plot 0 values, y equal to 0 as blue and y equal to 1 as red. Okay. So, so this is x1, this is x2, and these points are y equal to 1, these points are y equal to 0. Okay. Is the data clear, guys? Now, how do we classify this? So logistic regression only works when the boundary, when the separation boundary is linear. Okay, so here we can clearly see that this kind of boundary we can get. Okay, so once we get this line, we can say that, okay, points on this side of the line will be y equal to 1, and points on this side of the line will be y equal to 0. Correct? So the aim of logistic regression is to find a linear separation for the target variable. Okay, based on the inputs. So now let's say, and yeah, some more details here. So this line will be called as z equal to 0. Okay. So usually when we do linear regression, this is what we predict. We predict z. Okay. So the linear regression that we did earlier, it's like this, na? Theta 1, theta 0 plus theta 1 x1 plus theta 2 x2 equal to y. Okay. Y hat. So this is what we predict. Sorry, this is what linear regression is, right? So yeah, that's what we try to do. So this equation, this theta naught plus theta 1 x1, theta 2 x2, this is known as z. This expression is known as z. Okay. So this line is z equal to 0. So based on this line, we can say that, okay, this side it will be red, this side. Now, how do we say, like, how do we detect? Okay, so let's say I have x1 equal to 5, x2 equal to this. So after calculating z, I get the value -2. How do I know that which side of the line is it? Is it this side or that side? Any idea? I get z equal to -2 basically. So how do I know which side of the line it is? This line is z equal to 0. इसका मतलब होता है कि if I take this point particular, so this value is for x2, this value is for x1 for this point. If you put in this equation, you will get 0. Similarly, if I take this point, okay, you will take this x1 and this x2, you will put in the z equation, z expression, you will get z equal to 0. So whatever point you choose in this line for x1 and x2, if you put in this equation, you should get 0. So this is what this line is. Now I'm asking what if, let's say I have this point here, I have this new point, okay, and I calculate z. Okay, z for this. Like I put in this expression and I get z equal to -2. How do I know that this point is like it's on this side or this side? How do I know? Let's say I don't have this plot. I don't give you this plot. Okay. And I have z equal to some equation. Let's say 2x minus 2x1 minus 3x2 plus 10, like this. Okay. I put x1, x2 value and I get z equal to -2. So what should I do? What should I conclude? Okay. So it's like this. So if you take lines on this side, on either one of the side, okay. On this line, if you put this line will be z equal to 1. I say the farther you go from this line, z value will increase. Okay. All the points in this line will be z equal to 1, z equal to 2. Same way you will get a line z equal to 3. So you keep moving this side, you will go till z equal to infinity. Okay. Same way if you go this side of the line, you will find lines till z equal to -infinity. समझ आया? Z का as such कोई significance नहीं है. Z is just I'm naming this equation, okay? Because I won't be able to write again and again, right? That this thing is 0. So that's why initially I'm saying Z equal to Z is the linear combination of theta x1 and x2. That's all. Z is just the linear combination of x1 and x2. And this line, the division line is Z equal to 0. Okay. So basically Z is this, and what is the range of x? Range of Z? It's -infinity to +infinity. But I want, so this becomes, if I try to do this, this becomes again a regression problem, okay, which I don't want. So how do I convert that? Like I want a formula which converts this to probability. Okay, since this is a classification problem, I want answer in like what is the probability of having a value 1? Okay, let's say I want this. So what will I do? So the point is, this line is z equal to 0. This side, my prediction is y equal to 1. And let's say I'm calculating the probability of y equal to 1 using logistic regression. So at this line, at the division line, what should be y, like what should be the probability of y equal to 1 in the division line itself? Let's say if I take this point, which exists in this line, what should I say? Is it blue or red? 50-50, na? Very good. So here at this line, probability I want is like y cap. Probability we'll call y cap 0.5. Now at a very far away point, okay, very like let's say z equal to infinite line, z equal to infinity. What's the probability of y equal to 1? What should be that? If my point is here, should it be red or blue? Red. So probability of y equal to 1 should be very far away. It should be 1. There is, because it's very far away from this line. So there is no chance that it can be a blue line. Okay. Same way, if z is -infinity, it should be, the probability should be 0. We are talking about probability of having y equal to 1. Okay. So if I have at -infinity, that means y equal to 0. So probability of y equal to 1 will also be 0. Getting it? Similarly, if I have something here, if I have a point here, okay. Now here, it won't be 1 exactly. It should be greater than 0.5. That's it. So that I can assume that, okay, greater than 0.5 means higher chances of having 1. Okay. Here we have a short chance of having 1. So the farther away we go from this line, the probability of y equal to 1 increases. The farther away we go from this line, like this side, the probability of 1 decreases. So basically, I want a formula which converts like the range -infinity to +infinity to 0 and 1. Getting it? Now that formula is known as sigmoid. This will be your sigmoid formula. So try putting it. So try put z equal to 0. If you put z equal to 0, what is the value of sigma that you are getting? You will get 1/2, which is what we wanted. If you put z equal to infinity, what will you get? Infinity as in very big number. What will you get here? So e to the power -infinity will be 0. Very good. So this should be 0. If you put this, you will get sigma equal to 1. Great. This is what we wanted. Same way, if you put z equal to -infinity, you will get 0. Because this becomes, if I put z equal to -infinity, so e to the power infinity will be infinity. So 1 upon infinity is 0. Is this clear? So if I try to plot sigmoid, it looks like this. Sorry. Okay, let's say this is z equal to 0, and here z is increasing. Z is going towards infinity. Here z is going towards -infinity. Okay, and this is sigmoid. So this value is 0.5, and it is increasing as it moves towards infinity. Its value is moving towards 1. And as it goes towards -infinity, sigmoid is moving towards 0. Okay, any doubt in sigmoid, guys? So you have y values 0, 0, 1, 1, 0, 0, 1, okay, like this. And you have to predict y cap. So y cap will not exactly be 0 and 1. Okay, like it will be probability of having 1. Basically, the closer it is to 0, it will be 0. The closer it is to 1, it will be 1. Okay, so y cap will look like this. So let's say 0.12, 0.2, 0.75, 0.92. Okay, so it's corresponding to these values. Okay, this will be the kind of prediction we will have. Getting my point? And the formula to get y cap will be this: 1 upon 1 plus e to the power minus theta 0 plus theta 1 x1 plus theta 2 x2. So aim of logistic regression again to find the optimal value of theta 0, theta 1, and theta 2. These are called model parameters. Okay. So this is similar to linear regression only. Like in linear regression, also we find theta 1, theta 0, theta 1, theta 2. Here also we are finding that, but the formula is a little bit different because the use case changes. Linear regression is a regression problem. Logistic regression is a classification problem. Okay. So this is the formula for logistic regression, which is sigmoid of linear regression. That's all. Okay, that's logistic regression. It's sigmoid of linear regression.